last week and I'm still not doing it. Okay, talking about the final exam. If you have a question, feel free to text me, but think through like, would I ask this? Oh my gosh, a bird just came up to the window. That was very frightful. He like stopped right in front of my face. Okay, sorry. So think through of the question that you want to ask me and whether that's something you think I would answer if we were in a classroom setting. If the answer is yes, please do ask it. I want to be helpful. If there's any questions that are kind of ambiguous or you're not sure about, again, that's my role. I want to be helpful to you guys, but I'm not just going to give out answers either. I don't think that that would help you or would be appropriate for the class. So, any questions about the final exam? Okay. It is not cumulative in terms of, I'm not going to ask you back questions on like what's a median. I'm not going to have you do those calculations again. It's going to focus on this last half of the class, but some of it inherently builds upon. So, um, anyway, you guys will rock it. No worries about the final exam. Okay, if you have any other questions that somehow I didn't answer or all of a sudden you panic next week and you want to reach out, please don't hesitate to do so. And I will make sure to answer questions as best as I can. Okay, so let's take a quick moment and look at Course Connect. Can everybody see Course Connect?
Yes.
Okay. I don't know why I have so many things here. I'm just going to hide a few things so it's not as messy. This was last week, so I guess I was right. I should have just left this right here. We are going to cover regression. Let's talk about the data analysis. This is the big piece here. So here are your instructions. You must run 8 separate analyses using this data set below, the General Social Survey 2012. It is an Excel spreadsheet. You can open it in Google, I think it's Google Sheets. If you have a Mac, you'll be able to open it as well with numbers, I believe. But this is the specific data set. So you have to run 8 analyses. Of these, you need to include the following. So for each analysis, state what is your hypothesis. Next, copy and paste your results from your Excel analysis. So what is the result of that analysis? And then next, include a sentence or two about your interpretation of the results. And lastly, do you confirm or instead, do you reject or fail to reject the null hypothesis? Okay, so you need to include all of this for all of your analyses that are specifically involved, like inferential statistics, not descriptive statistics. I'll describe that in just a second. Okay, so again, this is my expectation here. Okay. Of your 8 analyses, the following must be done. You need to have 1 crosstab, which we've practiced several times using a pivot table, 1 correlational analysis, okay? So this is, again, in Excel, you can do a correlation using the formula. And lastly, 1 tailed independent t-test, which we practiced as well. So those are the 3 that you will need to complete, okay? So those are 3 analyses. Now, let's continue on. You must also include 3 basic demographic analyses. One must be a frequency table with a histogram, and 2 others which show mean and standard deviation. Okay, now some quick math here will show you that that's 3 analyses right here, and that's 3, so that's 6. So you have 2 that are completely your choice. You get to do what you want to do with it, okay? So you will need to write up all your hypotheses and copy your results into a Word document, save it, and you will submit it here. So again, you're writing your hypothesis, copying the results from your analysis, write a sentence about what the results mean, write a sentence as to what do you do with your original hypotheses, and you do that for all your interpretations. Okay? Now, this is a massive survey, Okay, in fact, I have it right here. Let me move it over. Can you guys see this? Yes. Okay.
Yes.
Awesome. So first off, this is the bar that's showing you how many like how many questions there are. Okay, do you guys notice this? I am still scrolling. Okay, lots of data. Okay, if we go down this way, we're in like 22, like it's thousands and thousands and thousands. Okay. What I love about this data set is it contains tons of information about people's views in the United States. It's not only so there's a lot of social, political, ethical views, but there's a lot of demographic information with it, and it is freely available. Okay. So I want to make sure everyone is seeing this. At the very top here, you'll see there's the year, the ID. We don't really care about that. And then see, this is WRKSTAT. I don't know about you, but I look at that and I'm like, I don't know what that means. Okay. WRKSLF. Maybe I would interpret that as work self. OCC 10, marital, divorce, right? Okay. This here is the title of the specific variable. It is not clear at first glance what any of these numbers mean, right? So we need access to a code book. So if I minimize that and I go back over here, you guys can all see Course Connect. Okay. This here is the Excel spreadsheet we were just looking at. This here, and I don't know why it's not a hyperlink. I messed with it earlier this morning and it doesn't work. So just copy it and then open a browser right up here. Okay. You can see I've had it open a few times. This is the GSS Data Explorer. Okay. For any variable that you are curious about, you can enter it right here. So let's pick a random one. Okay. This main D10. I don't know what this is. So I highlight it, copy it, and then I go over here and paste it. Press enter. And here it is. I can click on it. So this is mother's industry code. So it's asking about the occupation of the respondent's mother. Okay. It's a weird date. Like, I don't know that you would want to use this variable, but if you did, here are all the codes that go with it. So if somebody wrote 590, that would mean they're in the electric and gas and other combination. That's their industry. Carpet and rug mills is 1570. Coding, engraving, heat treating, and allied activities. You can see there's just lots of random stuff. Maybe I picked kind of a really esoteric one. Let's go back over here. Marital. Let's pick marital. Okay. So if I minimize that again, now I'm up here. I would go back to variable results. Okay. Here we are. This is where I plugged it in. I would highlight this, paste the variable I'm interested in, which is marital, press enter, and here it is. This is marital status, okay, which we probably could have figured out from the name of the variable. What we don't know is what does each response mean? So here is the code book. If they notated or answered 1, that means they're married. 2, they're widowed. 3, they're divorced. 4, they're separated. 5, they've never been married. And 9, they did not answer. Okay. Furthermore, I'm not sure that you necessarily need this information, but just so you're aware, you can scroll over to 2012 and see the breakdown of all respondents and their marital status. So no one skipped that question. No one marked 9 as no answer. You see 900 said they were married. 163 said they were widowed. 317 said they were divorced. 68 stated they were separated, and 526 stated they were never married. Okay. So again, when you go back to the data set here, you need to think about everything you learned in this class to figure out which variables do I want to use to calculate the specific analysis that I need. Okay. So if you need to do a crosstab, you need to know about what type of variable needs to be in there. If you want to do a mean and standard deviation, I would highly recommend that be an interval ratio item. Okay. So again, you can look through here to see what is available. You know, this might be a helpful variable for you. Age, because that is definitely interval ratio, right? Where they're just inputting their own age. Okay. This is another interesting one. So this is, I explained this to another class earlier today, but it's the age of the respondent at the time they had their first child. This number is shocking, gang. It starts at age 9. I mean, my jaw dropped when I was like, what? And it goes all the way to like 65. I don't know, just fascinating. I don't know if anybody else thinks that's kind of interesting, but like, whoa. Again, you've got education. You can really scroll through and see like, again, these are just grandborn. Like it's not necessarily obvious what it means just based on the title of the variable. This is why I'm giving this to you guys now. So you have a full week to get it completed because you need to get familiar with this. Now, you can also work backwards. So if you go back to variable view, okay, and let's say you're interested in years of education. That's what you're interested in, but you're not sure which variable it is. So you can do it 2 ways. One is you can scroll through the data set like I was doing and looking at the variable names and going, oh, that might be interesting, and then searching what the code book is. Or you could say, I'm interested in looking at years of education and race and ethnicity, for instance, which is something we did a little similar before. So you could write in here, education, press enter, and then you see all of the variables that have to do with education, okay? Non-college post-secondary, improving nation's education system, sex education in public schools. So that's taking it a totally different way, right? This is going to be their views on whether sex education should be taught in public schools. Educational level, right, for different people. So it's going to ask them different questions. Contributed money in education. How many hours spent or volunteering in education? Okay. So tons of information. Here's another interesting one. The government's responsibility. Should they provide financial help for education? So you'll see there is so many variables in this data set. So if you are curious about something specific, type it in and see what variables pop up. If you would rather just look at the data set and pick some random variables and then plug them in here to figure out what do they mean, like for instance, this last one, government responsibility, provide financial information help, provide financial help for education. Wow, I couldn't get that out. So few things. This was only asked in 2006. Will this help us? Can you utilize this variable for the project? This is the General Social Survey from 2012. So, can you use this variable?
No.
No. They did not ask this question in 2012, okay? So I would need to go back and see, let's see, education level person 1, for instance. Oh, they still didn't have that. So this is one of the pitfall of doing it this way. No. Yeah, so doing it this way might prove to be a bit more a little bit more challenging because we might not know which year. Okay, okay, I've got another idea. Control find. Oh, see, yet they don't have any. Huh. Oh, okay. Hold on. Okay. PAE. Again, I don't know what that stands for. Can you guys figure that out? Ah, okay. Highest year of school completed by the respondent's father. That's one of the variables included in the 2012 General Social Survey, okay? You can see here 2012, here it is. And this is years of education. All right. Are we kind of understanding how you can manipulate this and how to get the answers that you need for our class? What questions do you guys have for that? Or is this super clear? Are you like, I will have questions, but I need to absorb this first, and I will be texting you later on? That's okay too. Okay. Maybe we just leave it at that. That's all right. Okay. So you will find this on next week's page, the April 26th to May 2nd. Go through it, download the file, highlight this. Again, this is a really good tool. And then make sure that you, whoops, wrong thing. Here we are. Make sure that you read the specific analyses that are done. It would be even helpful to me if you wrote, if you organized your specific analysis by writing the analysis you're doing at the top. So for instance, writing 1, frequency table and histogram, although that's going to be a simple one. I'm going to be able to figure that out. Then you could write mean and standard deviation. And then afterwards, continue with crosstab, correlational analysis, t-test, just so it is clear for me that you've actually completed the required analyses per the special project. And then you have your final 2. So remember, there's 6 here, but you need 8 in total, okay? Okay. I'm just gonna leave it here then if everybody's feeling pretty good about it. All right, I will trust that you guys will ask me questions as it gets closer. And if there's anything that's not making sense, please do let me know. And again, sooner the better. This is gonna be due next week, Wednesday by midnight. That's your final exam. Why don't we make this special project be due Friday, the 30th? So 2 more days by midnight. Did you guys just get happy about that? Did that just, oh, yay! Okay. So final exam is next week, Wednesday at midnight. Camilla, I love the little fireworks explosion. That's cute. All right, so final exam, Wednesday at midnight, special project or data analysis assignment, Friday the 30th at midnight. Make sure that that is included. Okay, good. All right. Any questions for that, or we're all good? Okay. Let us start then our lecture. Can you guys all see this? Let's see. Let's get it. Slideshow. Do you guys see it big or small?
It's big.
It's big. Okay, good. It's kind of embarrassing. We're the last week of class and I'm still like, did I do this right? Technology is just not my friend sometimes. All right, so the very last piece is regression and correlation. So some of our goals for today, is going to be how to describe linear relationships and prediction rules for bivariate and multiple regression model. Okay, we're just dipping our toes into the regression pool because it is really far more complex than this class really commands. So if we were in the lab and we were running SPSS, I would show you point, click, how to do a multiple regression, takes 2 seconds. In Excel, it's actually quite complex. You need multiple tables. So yeah, we're not going there. But the goal of tonight and for the final exam, what I want you guys to know is what is a regression and how does it actually predict things? Like how is that a thing? How is that possible? So that's the goal for tonight. We are not going to be constructing straight line graphs, but we will be interpreting them. We will not be calculating an alpha, a beta, but we will be interpreting it and understanding what they are. And then we will talk about the coefficient of determination and Pearson correlation coefficient, which we've kind of talked about bivariate correlation already. And then we'll look at what is a multiple regression output in SPSS and what does that mean? Okay, this last bit will just be integrated as part of it. All right, so first off, what is a scatter plot? And the reason why we're bringing this up is that's what ends up happening when you have a line of prediction for a multiple regression. The way we calculate it is we measure the dependent variable and independent variable, and we actually graph each results, and we see if there's a line of best fit. And specifically, that ends up being a scatter plot. So again, it is a visual method used to display a relationship between two interval ratio variables. It's the first step. It's really exploratory. If you're not sure if there is a relationship and in what direction the relationship ends up being, you can take a look at the scatter plot and that'll give you a hint about it, okay? A correlation is a measure of association that is used to determine the existence and strength of the relationship between the variables, okay? There's 3 options. Let me see if I can do a little bit of this real quick. Okay, so this is an option. Oh, that was bad, but you get what I mean. Or that. Okay. Did we talk about all this already a little bit? Yeah. So what kind of relationship would variable X and variable Y have here?
Positive.
This is a positive relationship, okay? And how do we know?
Because they're both increasing. Or like it could be like they're both decreasing, but they're both going the same way.
Exactly. As one variable increases, the other variable increases. So, you know, you increase one. So the more I go to the gym to lift weights, not to sit in the hot tub, the more muscle mass I build, right? Okay, so you increase one, you increase the other. Okay, that's the relationship. Let me make sure there's not, no, okay. What about this? What kind of relationship is that?
Negative.
That is a negative relationship, right? Okay, as one variable goes up, the other variable goes down, okay? So, I don't know, what would be a good example of that? This, again, I don't know, workout seems like it's easier. The more I work out, the less I weigh. Okay, that could be an example. What's going on over here?
It's remaining the same or stagnant.
Okay, and what does that indicate as to the relationship of the two variables?
That there
It's
is
neither. Yeah.
oh sorry.
Oh no, go for it.
That there is no relationship.
There is no relationship, okay? We cannot determine or predict that as one variable moves, the other variable will move accordingly. This is really showing no relationship. This would be like me saying whether how old you are and oh gosh, everything I want to give as an example, I'm like, I think there might be a relationship in that. I was going to say how much money you spend on Starbucks. There's probably a relationship there. But how old you are and the number of black shirts you own. Probably no relationship there. Unless you guys disagree with me and you can make a case for it. That's cool. But, some random thing. Like one is not impacting the other. Okay. A few more definitions. So a regression, which it can also be known as a prediction, is a linear prediction model using one or more independent variables to predict the values of a dependent variable. The whole goal of multiple regression or even linear regression is figuring out if I make an alteration in this variable, this independent variable, where can I predict the other variable will land? Okay. The goal is prediction. So I want you guys to take a step back real quick and think through about car insurance. Okay, which I know is a super exciting topic. Have your parents talked to you guys, or I don't know, maybe some of you guys pay your own car insurance. What do you suspect is the relationship between age and car insurance cost?
Age is experience.
Age and experience. What did you say?
Yeah, age and experience. So like the safer you are, the older you are, you hopefully have more experience.
Okay, so somehow the older you are, the less you would spend on car insurance?
Yes.
Okay, all right. Now, let's say I'm 85. I'm old and very experienced. What do we think about that?
Well, that also could be unsafe, but
Right.
you'd have to pass still to have a license, pass eye exam and all that.
Yeah. So what I'm hearing from you, and was it Annette? Yeah.
Yeah.
That there's a relationship between age and how the car insurance company is assessing or predicting how safe of a driver you are. Okay. Because your car insurance rates are based on actually actuarial statistical data, right? What are some of the factors you think they count about? So Annette talked about, I'm going to try to write, guys, and this is never very pretty, but age or experience, right? So that would be a factor they would consider. What are some other factors?
If you've gotten a crash before.
Okay, so past crashes. Okay, what else?
Tickets, like speeding tickets.
Tickets. So I'll write violation, right? Some sort of violation. Okay. What else?
Like the car itself.
So the type of car. Oh, that's an A. Anything else?
How many people are on your insurance, I guess.
Okay. What else?
If you have full coverage or not.
Okay. Full or partial. Okay. What else? That's coverage, you guys. That is so unclear. That's going to bug me. I'm just going to ignore it. What about location? Yeah?
Definitely.
Okay. Do you think there's a price difference if you tell them you live in, LA versus super rural Idaho?
Yeah, there's probably statistics on more crashes in LA than rural.
Yeah. What about job? Right? I use my car to deliver pizzas, or I'm an Uber driver, right? Versus I work from home. I don't drive anywhere. Okay. So we've just come up with 8 different factors, or what we consider are independent variables to determine what? What is the dependent variable we're trying to determine here?
The cost of the insurance.
You're very close. So we're trying to figure out the cost, but what is it the insurance company is actually trying to figure out?
Would it be risk analysis?
Risk analysis. Was that Hannah?
Yeah.
Great job. They are trying to figure out the risk, right? From there, they go back and they adjust it to a cost. Okay, so the dependent variable is how risky of a driver is this person going to be? And the independent variables are how old are they? How long have they been driving? Have they been in a crash before? Have they had tickets before, other moving violation? What type of car do they drive? How many people are using this car, right? Are on the insurance? Are they looking to get full or partial insurance? Where do they live and what do they do for work? Okay. So all these independent variables are trying to predict the level of risk. Okay. Which then leads to how much they charge you. So if you tell them, I'm going to make stuff up here. And I'm not trying to be ageist. Just, okay. I am 20 years old. I've gotten into a car crash before, 2 speeding tickets. And I drive a red sports car that's been souped up and it's super cool. I don't know why I'm talking with an attitude, but you know what I mean. I'm the only one on my insurance. I'm just looking for partial coverage. I don't really want to spend a lot of money. And I live in downtown Chicago and my job is a gig worker. So I deliver Instacart, Shipt, Postmates, all those things. What's the insurance company going to say?
It's really expensive.
Give me all your money. You are high risk, right? So again, each of those individual independent variables, okay, if we look at this is like, again, what is our risk factor? And these are different independent variables. We could just pick one, for instance, right? Highest level of risk, right, would probably be younger drivers. If we pick age here, for example, okay? Young drivers are risky, and then it does this thing like that. And then old drivers are risky. So this is actually like a curvilinear relationship. Okay. So if you think, well, no, I don't think I agree with my own graph here. I want to give that some more thought. Because age, okay, let me think that through. I don't know why it's not, oh gosh, I'm erasing everything I don't want to erase. So who are we saying is high risk? It'd be old and young. Okay, I'm doing this over. It'd be almost like that. Right? So older drivers are maybe more risky because they've lost the ability to quickly press on the brakes. People that are middle age and have children riding in the back, they're white knuckling their car. They're putting the stickers, baby on board, watch out, I'm coming for you. And then maybe 18, 19-year-olds are like, you only get to live once. What is that called? YOLO? Yeah, YOLO, just drive through. I mean, I don't know. Okay, so high risk is at the high end and low end of age. Okay. Again, I picked age, which ends up being a curvilinear relationship. It's not great. If I did something like, well, anyway, okay, before I go on, you guys get the idea of this example, right? Independent variables can predict a dependent variable. Companies utilize this all the time. So actuarial data for insurance quotes is used all the time. So car insurance, life insurance, right? What are they looking for your life insurance? How healthy are you? Do you engage in risky behavior? When we got life insurance 6 years ago, maybe, we did a European trip and we're like, in case we die, we want our kids to be taken care of. So got life insurance. And they're like, do you bungee jump? I was like, what kinds of questions are they? No. where would I even do that? They're like, are you thinking about it? I'm like, no. I was just honestly curious. Like, that's a weird question. So they're assessing risk. Are you kind of a risk-taking individual, at which point you're at greater risk of dying because you're engaging in high-risk activities, right? Okay. So again, multiple independent variables that can help to predict a dependent variable. That was a long explanation just for regression, but anyway, those are fun examples. A bivariate regression is a model that examines the effect of just one independent variable on the values of a dependent variable. This would be this example here of age against risk of car crash. A multiple regression is a model that examines the effect of several independent variables on the values of one single dependent variable. So this would be the example of getting a cost, like what is the cost of getting car insurance, and because it's based on all these independent variables. Okay. Does that make sense? Hopefully, yes. Okay. So here is an example of a scatter plot. Specifically, this is a scatter plot that you would get in SPSS. That's what it would look like. Again, sad face, we don't get to experience SPSS because COVID. Let's just be mad at COVID again. Okay. So this is the relationship between perceived stress and road rage. Okay. If we were to draw a line of best fit, it would probably look like something like this. Okay. What kind of relationship do you suspect that is?
A positive correlation that's not like extremely strong, but still like fairly strong.
Mm-hmm. Again, that's one of the beauties of a correlational analysis, or even when you're doing a regression, is you get to talk about the directionality of the relationship, right? And the strength of the relationship. So this does imply a positive relationship. The greater your perceived stress, the greater your driving anger. So if you're really stressed out, you're more likely to engage in angry driving behavior. We've talked about this before. I'd be cutting somebody off, honking, absurd gestures, all the things. So that is the relationship between the two. Okay. You end up putting the independent variable on the x-axis right here and the dependent variable on the y-axis. Okay. So this is a scatter diagram for the educational attainment in internet hours per week. This is how many years of education they have, and this is the number of internet hours they have per week. Can somebody tell me what is the relationship between these two variables as you see it here? What do we think? What's the relationship?
So as years of education increase, so does the amount of hours you work online.
Okay, very good. So as Diana just described, as you go up in years of education that you've completed, you also go up in the number of hours you're on the internet. Okay. Now, by virtue of the scatter plot, I can make a prediction. Okay. If I know your level of education in years, I can predict how many hours you're on the internet. Okay. So most of you guys fall probably at like 13 or 14, right? 14. Are you guys mostly sophomores, juniors? Okay, hold on. I'm going to try to pull up all of your faces. Where is my cursor? Uh-oh. Okay, you guys are writing in the chat. Now I can't find my own mouse. This is an issue. Okay, here I am. Okay, my mouse just stopped working. I can't answer why. Okay, freshman, junior. Okay. 2 freshmen. Oh, it's a pretty healthy mix, actually. That's kind of hard. Okay. This is really going to bug me now. My mouse is not working at all. I'm just going to make this into a laser pointer that's more obvious. I'm going to turn it on and off. Totally died. Okay, hold on. Tech support. Looky, look. Can you bring this to Daddy and tell him to put more batteries in, please? Thank you. He's- Oh, are you guys hearing my boys negotiating now? Who's going to do it? Because we're both playing this game. I don't know if you guys can see them in this cube right there. Okay. All right, I'll use this mouse for now. So based on this, several of you wrote freshmen, right? So that'd be 11, 12, let's see, right here, 13. Oh, now I need to go back to this. Okay. 13. Okay. That would be 4 hours per week on the internet. How do you guys feel about that stat? Does that seem pretty right on? Oops. Does that seem right for you guys?
No,
No.
I would
That doesn't. No.
just
not
this class is supposed to be 3 hours.
right. That doesn't seem right at all. So again, this is data from whenever this was published. That doesn't seem quite right because I have, let's see, does it work? Oh, I know. Let's see. I still can't see my mouse, buddy. Oh my, okay. No, still not working. I need you to go figure that out upstairs. Thank you. Ask Daddy. Thank you. Thank you. All right. Sorry about all the interruptions here. So even higher years of education does not line up to me. Oh yeah, Hannah, that's a very good point. With the pandemic, definitely we're more online than ever before. But again, this may be due, like if we think about a year where this data may have been collected, maybe there was no access to internet on your phone, right? So if you think about just accessing the internet, not for school, but just browsing just on your computer, then yeah, maybe that's a little closer. But yeah, that seems like an underestimate. But you get the idea. So if I have a scatter plot, if I know one piece of information from you, I can predict where you will land on the dependent variable. That is the goal, again, of a scatter plot. Okay, so a linear relationship is a relationship between two interval ratio variables where the observation displayed in a scatter diagram can be approximated with a straight line, which is in fact what I just did earlier, right? You have a scatter plot and you put a line of best fit so that you know the directionality and what is the essence of the relationship, okay? A deterministic or perfectly linear relationship, by the way, is extremely rare, but it's a relationship between two interval variables in which all observations fall along a straight line, okay? So again, you've got this straight line that is constantly on the line. That does not happen in the real world, right? Because individuals break the mold, they break the rules, they break patterns, right? We are each so unique. We are not that predictable. This would be really going down the line of a deterministic lifestyle and the lack of free will, right? Which is not necessarily true in this world, especially with the number of choices that we get. Okay. So a little bit about regression. So it's a mathematical technique for predicting a dependent variable, and it's based on fitting the math model to actual data. Now, there's a few assumptions that we make with that. So first off, the dependent and independent variable, you're just giving that to me?
Yeah,
That's what Daddy recommended? Okay. We're gonna plug in a new mouse. Let's see if this works. It does work. Thank you. Thank you very much. Problem solvers. This works out really well. Let me switch this to my laser pointer. Okay. So a few assumptions. So first off, the dependent and independent variables are interval ratio measurements. You cannot put in a categorical variable in here, and certainly not a nominal variable. This is not what I wanted here. Sorry. I'm just going to close this. Okay, can you guys see the screen still without the installation piece? Okay. Okay. Variables must also have a linear relationship. That's another big piece of it. It's going to be a little harder. The example I gave you with age and crash is kind of a bad one because it's curvilinear. In this class, this would be much more advanced statistics where you'd look at that kind of model. But for the most part, they need to have a linear relationship. You can also use a dummy variable techniques for any sort of nominal or categorical variable. And here's how you would do it. It's not great. Let's just start with that, but it is possible. So you would recode a specific variable to be 0 or 1. So it's essentially creating a dichotomous variable. And what you would do, so something like sex, race, religion, for any of those, one of them would be a 0, the other one would be a 1. So you could then enter them that way. But obviously, it would be, and I feel like we just talked about this last week or the week before, like with race, it would be white and non-white, right? 0, 1. Or it could be African-American or non-African-American, right? You break it down to just a dichotomous variable, which inherently is kind of problematic. You're losing a lot of your variability and nuance within your variable by making it what they call a dummy variable, because you're just breaking it down into 2. Not great. But at least you could then enter it into a regression. Okay. So this is another regression technique. You've got age on the x-axis and hours of reading on the y-axis. So you see when they're quite young, right? How many hours are they reading? Well, not at all. They don't know how to read, right? As they get older, more and more reading, you get to middle age, that would be the most amount of reading. And then as you get older, less and less reading. Does this, if you guys think of like grandparents or other people in your lives that are a different age than you, would you say this relationship holds true or is different?
I work with the elderly, and I would say that they have any illnesses, like mentally, there's so many people with dementia that might be why the number goes down, because they don't really read as much.
Yeah, I think you're right. Like if there's any sort of physical or mental impact, then reading is likely going to go down. But I think about my mother-in-law, who is actually 75. And if I were to draw her curve, it probably, and maybe this is very idiosyncratic again, but it would be like, just straight up, because, she was raising children around here. So she was reading, but then she read a lot more once she retired, right? So for some people, it might differ a little bit, but for, I think, the mass majority, this is the path of the curve, right? You reach a point where you read less because your abilities are just not quite where they were. Okay. So finding the best fitting line. Again, this is what I did just a moment ago. So the relationship, again, between years of education and internet hours, what we looked at earlier, is not perfectly linear, right? In fact, you saw it kind of went up and then hit this plateau. It's not infinite. It's like if you have no education, you don't go on the internet. If you have a PhD, you're on the internet at all hours of the day. That doesn't make sense, right? That it's not a perfect relationship. It's not perfectly linear. So most relationships, again, in the social sciences are not deterministic, and we are not able to come up with a linear equation that allows us to predict the Y from the X with perfect accuracy. So just that needs to be a huge asterisk next to regression. We are able to make some predictions. However, none of them are going to be perfect or 100% accurate. So again, we're far more likely to find relationships that approximate linearity, where we can say with some level of confidence that there is a significant relationship between these two variables, and here's the nature of their relationship. But as to whether we can actively and accurately predict what the dependent variable is going to look like, it's going to be plus or minus a pretty significant confidence interval. Okay. We've talked about that for a reason, right? It's to introduce this amount of error. We're not perfectly good. It's not an ideal linear relationship. So there's going to be some level of error with it. Okay. So the relationship again between an educational attainment and internet hours can also be described with a specific equation. And hopefully this looks a little bit familiar to you, right? It's the equation for a straight line. So the y equals a plus b times x. That's the same equation for a simple regression. We're just plugging in different variables. So let's look what those variables are. Y is the predicted score on the dependent variable. X is the score on the independent variable. A right here is the y-intercept, or the point where the line crosses the y-axis, I should say. And B is the slope of the regression line, okay? So this is really what is going to tell you whether it's a positive or negative relationship and how strong of a relationship it truly is. Okay, so if I look again at this particular relationship, this is years of education and how it relates to number of internet hours per week. Okay, let me get my pen here. Okay, so note if I actually connect each dot, the line kind of goes like this, right? It has a bit of a curve. If I was a better artist, that's what it would look like. Okay, but for the sake of argument for this class, we're trying to create an approximate straight line. So this is a line of best fit. If I try to include every single dot in this diagram, this is what it would look like, okay? And then I can see for somebody who has 21 years of education, which would be like somewhere here, their actual internet hours is 8. So this is where it would be. That is my intercept, so that I could plug in the information here from the slope. Now, let's pause here for a second. Are you going to be asked on an exam how to calculate that? No. I just want you guys to understand that this is just like the equation on how to draw a line, which hopefully you learned in whenever that was, geometry, 8th grade, 9th, I don't know, way back. So there's probably cobwebs in your brain, and that's okay. But hopefully it should look a little bit similar, that you can create a line and you can then it leads you to a prediction, right? Because in geometry, if you're creating a line, then you can pick any dot, any spot on the x-axis and predict where it will be on the y-axis. That is the same idea we're trying to get to here, except we're taking social constructs instead, right? Particularly this one, how many years of education do you have and how many hours of internet do you engage in per week? Okay, so how do we go about defining error? So the best fit in line is the one that generates the least amount of error, or it can be referred to as the least amount of residual, okay? So we're trying to get the line of best fit is going to highlight all of these data points with as little error as possible. Because let's go back over here real quick. I could say, oh, this is the line of best fit. Look at that. I included these 3 dots, but look at the amount, like how far I am from these dots, right? That creates a very high residual. That's not very good. The same way I could do it the other way around, right? I could go back and say, this is the best. You know, look at this. I've totally highlighted these, but there's huge amount of gap here between where the line is and the actual number. Not very good. Okay. So again, our line of best fit is going to be, you know, what has the least amount of residual. Okay. So think of the residual as the difference between the observed y and the predicted y, the same way I just did. So the predicted y is your line, the actual y is your dot. So The larger that gap is, as you add it all up for all dots, that's your residual. Okay. So it's the y minus the predicted y. So your actual y minus the predicted y. Okay. Our goal is to identify a line or a prediction equation that minimizes the error for each individual observation. So we want this E to be as tiny as possible so that we hit it almost spot on, right? What we predicted is almost identical to what actually happened. Okay. The residual sums of squares, a prediction equation that minimizes the residuals over all observations. Again, you don't need to calculate that. I just want conceptually for you guys to get what that means. With the line of best fit, we are trying to get as close to possible to the true values within our sample. All right. So again, the best fitting line, another way we can talk about it, is the least squares line. It's a line where the residual sum of square is the smallest possible. So that's almost identical to what I said. So if you add up all the residual, you want it to be the smallest number possible. So it's your least squares line. Okay. Yeah, that's all I want you guys to know about that. I'm skipping all this because I don't want you guys to be like, oh, I'm melting. This is awful. I'm going to have nightmares tonight. Math. You don't have to calculate this. Yeah, I don't even want to point to it. The biggest thing right here, slope of the line, y-intercept. These two should ring a bell back from geometry. We're doing the same thing, okay? All right, there is covariance within all of this, which makes sense, right? Because the two variables are going to vary, right? Independently. They're going to have a mean and standard deviation, and they're going to vary. And when you put them together, they're going to covary is what it means. This is all I want you to know about this slide, okay? We just go here. So how do we use a regression model to get predicted values? This is the name of the game, right? We want to get good in the social sciences to be able to predict. Prime example, right? Admission scores or admission calculations for college. College admission groups, what do they take into account? What are some things that they look at before they let in a student?
GPA and SAT or ACT scores.
Okay, very good. So pass GPA and then standardized scores, right? And that may be SATs or ACT, depending on where you are really geographically around the country. What else?
Extracurricular or sports or special
Yep.
interests.
Curricular. Sure, we're going to go with that. And then right, sports. What else?
Volunteer work, maybe, or
Okay,
hours you've done volunteering.
good. What else?
They may look at the type of classes you took, like regular versus like honors or AP.
Okay, so maybe what would we want to classify that? Like the challenge of high school classes? Okay. Challenge of high school. Okay.
Maybe what type of degree you're pursuing.
Okay. So coming in, if somebody is saying like, I'm going to be pre-med, that may, play a role as to whether they get admitted. Is that what you mean in that?
Yeah, or like if they already have a lot of students that are all, going into science major and they have, nobody for an English major. So they want more of those or something.
Right. Oh gosh, how would you guys have felt if you are admitted, you are now a pottery major? You'd be like, wait, what?
I'm
I didn't
thinking
sign up
of,
for that.
I'm
Or
thinking
maybe
of,
that's fine, not dogging on, fine arts, just, yeah. All right, so we've oh, go ahead.
no, you're fine. I was thinking of Legally Blonde because she was a fashion major and got into law school for her different degree.
There you go. To not be just like everybody else. Totally. We just watched an episode of Modern Family, obviously a very old episode where Alex talks about wanting to go in college, and she is identical to every single other applicant, right? Because it's like you almost get this path and then there is no variability. So how do you determine one from the other when they're all identical? That gets to be really challenging. But these would all be independent variables that are considered by an admissions committee for college, right? Ultimately, they're going to look to these independent variables to predict what? What is it they're looking for? What's a dependent variable here? Right, because all of these are independent variables. What's the dependent variable? Oh, that's a D. You're like, we don't know. How did we make it in? We still don't understand. Yeah, what do we think the admissions committee, what are they looking for? Because I mean, you guys are all right. All of these factors are considered before saying yes or no. I would say the dependent oh, go ahead, Diana.
I'm sorry. I was just going to say that would the dependent variable be like whether or not they were accepted?
I would say no. And here's, it's such a minute thing, but yes or no would be one of those variables that's not interval ratio, right? So I guess you could make it a dichotomous variable, like we're talking about the dummy variable, 0 or 1. But I think in this case, it's college success, right? So that's what they're trying to determine. Who's going to be successful in college? And that's likely to be operationalized by multiple factors, but mostly they're probably interested in matriculation in 4 years. That's probably the biggest indicator, because if you think about schools getting accredited and all, you know, these bodies that are much bigger than just the university itself or a college itself, they're looking to make sure that students are getting the education that they deem is, you know, acceptable, right? Whatever degree that you're in. And that's, there's low rates of attrition, meaning students aren't dropping out. They are successfully matriculating through their degrees and eventually graduating with their terminal degree, whatever that is, bachelor's, you know, master's or doctoral degree, within the number of years that's outlined by the university. Okay, so this is just another example, right? This could be fleshed out to look differently or operationalized differently. So this, I would say matriculation in 4 years would be graduation rates. So it'd be a percentage. So they might be able to say, oh, kids with high GPA have a high rate of graduation after 4 years, right? Or students with SAT scores that are quite high also tend to graduate. They have a high rate of graduation after 4 years. Okay, so that would be the relationship of the two variables. Okay, that is how you can use the regression model to get to a predicted value. Okay, I want to dive in just quickly, so because interpreting is a big piece of this class. So if we look at what's highlighted here, so the B coefficient, right? If I go back to my last slide, which is right here, this is my equation of a line. B in this case is 0.62. So first thing you need to note is this positive, okay? So let's look at what it means. So 0.62, this tells us that with each additional year of education, this is going back to years of education and number of internet hours that one is attending to. Internet hours per week is predicted to increase by 0.62 hours. So if you increase the level of education by 1, you are increasing the number of hours on the internet by almost 1, 0.62, okay? We don't expect our regression equation to make a perfect prediction. That's never the goal. That's not reality. And the y-intercept A if we go back over here, this is A, okay, right over here, which ends up being this value, is the predicted value of Y. So when X is 0. So if X is 0, Y is at 4.68. So even with 0 years of education, we would say they get 4.68 hours of internet, which is kind of frightening. Our little babies, they're just plugged into the internet. But again, as a general rule of thumb, this is key right here. Be cautious when making predictions of Y based on values of X that are outside the range of the data. So if you are not actually asking people that are under the age of 18, or, you know, I'd have to go back to see what that looks like what's the lowest range of education, don't make predictions that way. Similarly, if somebody's got, and this will make sense, I've used this example before, I think in my research class. If somebody has 3 PhDs, they just couldn't quite figure out what area they want to go into, and they're like, I've got lots of money, or I love student loans, and they decided to pursue 3 PhDs, right? So if you think about it, you've got probably 16 years of education up to a bachelor's degree. Let's say you got a master's alongside your PhD for your first one, that's 5 years. So 16 plus 15, 31 years of education, right? That's a lot. It does not exponentially go up, right? Like it wouldn't make sense to extend the line to go, well, they have 31 years of education, therefore they're on the internet 125 hours per week, where all of a sudden it doesn't make sense, right? Like, well, I guess this person doesn't sleep. They're just constantly plugged into the internet. So you have to stay within your range of data. You cannot extrapolate outside of it. It's likely not going to be accurate. Okay. Does that make sense? Okay. Hopefully that's making sense. All right. So positive and negative relationships. This is not new to you, but you know here, if you have a perfect one-to-one relationship, right, it'd be Y equals 1x. If you have a gentler slope like this, it could be Y equals 2 plus half, or 0.5x. You can also have a negative relationship. That would be minus 0.33, minus 0.2. So that's every time you go down 1, you go across 2, okay? Just like that. Again, it's just like a slope. Hopefully that's ringing a bell back to geometry for you guys. Okay, we're gonna skip some of this information because we get really down in the weeds with calculations, and I want us to just stay big picture, big concept, okay? Okay, do you guys remember with an ANOVA, we talked about looking at critical cutoffs and critical values for F? So if you have a critical cutoff and your value for F is greater than, then it is statistically significant. This is what you would get in terms of an SPSS printout as to whether there is a significant relationship, okay? So you would need to look at this F value and figure out from the degrees of freedom whether that is beyond the critical value. If it is beyond the critical value, then you can reject your null hypothesis. That's how that goes. Okay, so this would be my degrees of freedom. So degrees of freedom 1, and then the second one is 8. It'd be 238.9 right here. I think I'm doing that right. No, right here. See, it's good. 5.32. Okay. So I would be able to reject the null hypothesis at the alpha of 0.05 based on this. This is 1.75, and I'm looking at degrees of freedom 1. So over here, I'm grabbing 1. Degrees of freedom 2 is down this way. I get to 8. This is 5.32. Okay. This is the calculation if you were doing it by hand to calculate a Pearson R. Okay, the Pearson R is actually just the square root of R squared, which is variance. It's a measure of association between interval ratio variables. It shows both the strength and the direction of the relationship between the two variables. Okay, so it is defined as the covariance of X and Y to the product of the standard deviation of X and Y. Okay. Again, you're not going to be calculating that by hand. I just want you guys to note that a correlation is how the two variables come together and how they covary together. Okay. This is very important. This will be on the exam, and I've talked about this before, so that's why it'll be on the exam. The Pearson's correlation coefficient, or R, always ranges between 0 to 1 or 0 to -1. You will never have a Pearson R that'll be -5. Never going to happen. Okay. -1 to 1 is the range. The closer it gets to the ones, those two extremes, the stronger the relationship is. When you get to 0, that is indicative of no relationship. Okay. That there is no association between the two variables. That is how we measure the Pearson correlation coefficient. Okay, this would show a strong positive relationship, a strong negative relationship. This is more of a moderate positive relationship and a weak negative relationship. And again, if you had a graph that looked like this, well, it's kind of angled down now, but it's mostly, this would be like an R of, you know, okay, the way I drew it is probably 0.02. Ooh, that's a 2. That's awful. That's pretty much a no relationship, that there's no association between the two variables. Okay. Again, we have talked about this before, right? So this shouldn't be brand new material. So hopefully you guys are all on board with that. Okay. Okay. We cannot run this because obviously we don't have access to SPSS, but you can take a look at this. There's an example in your textbook that's kind of interesting. It's how much, so your ability to detect whether people are doing a fake smile. Like, I'm sure all of you guys could come up with a fake smile, like, this is great. What's her face? What's that model that always talks about smiling with your eyes? Am I making sense? Do you guys know what I'm talking about? Tyra Banks, I think that's her name. She always says smiles, right? Like you have to put your eyes into it. Anyway, there's a psychological theory that shows that somebody could, their mouth, if you went like this, right? And you're sawing this, but if you see their eyes, you're like, they're not actually smiling. They're not emoting happiness or joy. They're simply moving their mouth in such a way that it looks like a smile. I'm not getting an acknowledgement from anyone. Do you guys know what I'm talking about here? Are you like, she's crazy?
I know what you mean. Yeah.
Thank you, Savian. I need a little validation here.
No problem.
It's especially hard right now when we're wearing a mask, right? I feel like I am especially emphasizing my eyes so much more so people can see my reaction. Okay, so people's ability to detect whether somebody is genuinely smiling at them versus just, you know, kind of, okay, that's great. And then they took a specific survey to see what is their scores on a scale of needing to belong. So it's not really a neediness piece. It's more like how much are they interested in belonging and feeling part of. So their ability to detect whether somebody actually is genuinely smiling at them and their desire to belong. You could look at those two things and see if those are actually correlated, right? So the greater their ability to detect it, maybe the greater their ability or their sense or desire to want to belong to the group. You could input this data into SPSS, which is, again, fancier version of Excel, and they would spit out for you a correlation coefficient. And from there, you could see the strength of the relationship. You could do the same thing in Excel, depending on the version of Excel that you have. If you go to YouTube and you say, how do I do a correlation? It'll spit out. You start by pressing for all of them, you start by pressing equal and you start typing correlation, and it'll tell you to highlight the specific cells that you are curious about. So hint, hint, for the special project, that's what you'll be doing. You highlight the cells and then it'll spit out a correlation coefficient. Okay. Okay. All right. So what is the write-up? We'll talk about that later. Okay. Now, there can be spurious correlation or confounding effects. Again, this is something we have talked about before in our class. We are trying to limit confounding variables as much as possible. A confounding variable is a variable that actually is impacting your dependent variable equally or possibly more than your independent variable, but you are not actively researching that variable. So you may be coming up with some conclusion as to the relationship between an independent variable and dependent variable that is in fact much weaker and does not explain away the relationship between the two as much as this confound. That's actually, oh, that's the reason why. Okay. Okay, so this first example, the correlation between race and domestic violence. So this was a study that was done in 2004 by Benson and his colleagues. Studies and reports have consistently found that rates of domestic abuse are higher in communities with higher percentages of African American residents. This was their theory as they were going through the literature review. They're like, this seems to be really something that's present. What does it all mean? So their question was, would this correlation indicate that race and domestic violence are causally related? Meaning you will see higher rates of domestic violence if you are in an African-American community versus a different racial or ethnic group, okay? So to suggest, again, that African-Americans are more prone to engage in domestic violence is flat out erroneous, and if not outright racist. So we got to be very careful. But if the data is supporting that, you got to start digging under and say, that's surely not the reason. There's got to be another variable that is explaining that away. So Benson and his colleagues argued that the correlation between race and domestic violence is confounded by the level of economic distress in the community. Okay, so this is the confound. It is not, in fact, that these two variables have a relationship. It's this hierarching, overarching variable that is socioeconomic status that is far more predictive of domestic violence. Nothing to do with race. Are you guys following me so far? Okay. But in the specific articles they had pulled, past literature review, they had been done in really low socioeconomic status neighborhoods. So we've got a confound right there. So economically distressed communities are typically, and again, in the studies that were done before, they were occupied by a higher percentage of African Americans than other racial and ethnic groups, okay? Also, they found the rates of domestic violence in those communities were much higher than in other communities. So we've got two parts that are going on right now. So we can then say that the relationship between race and domestic violence is confounded by a third variable, and that third variable is economic distress or the level of socioeconomic status within that community. Okay? Does that all make sense? Hopefully that kind of tracks. So it's more important to look then at high and low economic distress in both African American and Caucasians to then see if there is, in fact, a racial component to that, okay? And it showed, in fact, that it was not significant when the level of economic distress is held constant. So again, domestic violence is not impacted by race as it is by socioeconomic distress. That is the predictor, okay? That is where the link lies, okay? In a multiple regression, because right now we've been talking about a linear regression, right? And a correlation. In a multiple regression, you have multiple variables at play. So it's an extension of a bivariate regression where the effects of two or more independent variables on the dependent variables are examined, okay? So you'd be looking at the score of independent variable 1 and the score on independent variable 2, and then as it relates to the slope of each, okay? This is what's most often done. It is usually multiple regression because it's hard to just have a one-to-one, especially in the social sciences. It's very rarely just two variables at play. It's a multitude of variables. Just the two examples we came up with, right? We talked about specifically rates for car insurance, and then we talked about admission to colleges, right? We came up with like 5 to 8 independent variables. We would enter those into a multiple regression, okay? So then each ends up with a partial slope. So it's the amount of change in Y for a unit change in a specific independent variable while holding the other variables constant. So you don't allow the other variables to change. You hold them constant while you evaluate each other independent variable, okay? So this would be the spit out that you would get for a multiple regression analysis. Okay. So you see here, you see age and education. The specific dependent variable is internet usage. Okay. And then you see the relationship that age has specifically on, we look right here on, what do we call that? I want to make sure I'm looking at the right values. No, it's right here. It's unstandardized, not standardized. So age is slightly negatively related to internet use. So that means the older you are, the less you use the internet per week. And education is positively related. So the more educated you are, the more you use the internet per week. Okay. And you can see here the two significance values. So if we're holding values for p-value at less than 0.05, right, an alpha of 0.05, which means we feel 95% confident that these scores were not arrived to based on chance, both of those are significant variables. Okay, it means there's a significant relationship between the two. Are you guys seeing that? Okay, so the way you would read this output is you go over here, you figure out where your dependent variable is. It's internet hours. Your predictor variables are right here. It's education and age. You would go down here to unstandardized coefficient. This is your beta. Remember, again, your beta is the slope. And you would see the two slopes for it. And then you follow the line and you look at significance. Okay. Hopefully that's making sense. All right. The standardized slope coefficient converts the values into a z-score. So then you can look at that as we talked about with z-scores. That's really all I want you to know about this slide, that there's a connection between the two. Similarly, if we go back over here, you had r squared, right? They're right back over here. Those are multiple coefficients of determination, and then Pearson's multiple correlation coefficient. Don't worry about that. We are not going to be dealing with that in this class. But if you were given a spit out of SPSS, that's what they are, just in case you later on have some curiosity about it. Okay. We don't need to worry about the APA style because we're not writing that. And oh my gosh, how is it done? That's not right. Okay. Main takeaways for tonight's lecture. Okay. Know what a regression is. What is the best fitting line? And what do we do by limiting the residual, right? Those two things kind of go together. What is a multiple regression? How many independent variables are we dealing with then? And then specifically here, know how to get a scattergram or a scatter diagram or a scatter plot and how you can get the line of best fit from it. And then what is a slope? What does it mean about the relationship between the two variables? Okay. Hopefully you guys know about just basically a Pearson's correlation coefficient because we talked about this a little bit before this semester. Okay. Questions, comments, concerns? How are we doing?
Pretty golden over here.
Okay, good. That's what I want to hear. Hopefully no one's freaking out. That's not the goal. Okay, do you guys feel like you are equipped to take the special project, open up the Excel data spreadsheet and data set, and then look through the web page I gave you so you can identify each variable and utilize the code book and then run your 8 analyses? So far, oh, what's that?
I said, I think so.
Okay. For the final exam, it's going to be a lot of what we've been talking about in class, okay? So if you've had to do an analysis for a quiz, expect that it'll be on the exam in terms of math. For the remainder of it, I'm just interested in capturing your understanding of it. I am not a, what is the definition of, I hate that. It's not going to be that. Which maybe for this class, you're like, darn it, that would be easy to just pull up the definition. So sorry, that was the plan. It's not happening. So yeah. Okay, any questions that can help answer? If not, It has been a wonderful semester working with all of you guys. Obviously, take a look, next week, Wednesday, when you open up the exam and start taking it, my cell phone number is going to be at the top. If you have any questions, please don't hesitate to shoot me a text. And then make sure to submit your final project by Friday, the 30th by midnight. Okay. All right. Well, I hope you guys have a wonderful evening and best of luck and everything else that is to come for you academically.
Thank you.
Thank
right.
you.
Thank
Have a
you.
great night.
Thank you, Professor.
Thank you.